Hello, everybody. Welcome to my channel, Island Daily. My name is Dr. Amen, and I'm an optometrist. And today we're going to learn everything about LogMAR chart. So let's get started. So when I was studying LogMAR chart, the first question came into my mind was that why do we call it LogMAR? So the abbreviation of the LogMAR chart is actually logarithm of minimum angle of resolution, right? So now, what is this minimum angle of resolution? Now, if I take a 6 by 6 letter, right? Now, for instance, if I take a 6 by 60 letter, right? Now, taking its reciprocal, I will get 10. So this 10 is the minimum angle of resolution. And what does this minimum angle of resolution tells us? It tells us if a 6 by 60 optotype, the angle which this limb makes and this space, the angle which this space and this limb makes an angle of 10 minutes of arc, right? So it basically makes an angle of 10 minutes of arc. And a letter, an optotype of 6 by 6 makes an angle of 1 minute of arc, right? So 1 minute of arc is the minimum resolvable angle required to differentiate between to differentiate a space. If you're seeing these two dots as separate, because there must be an angle, there is an angle of 1 minute of arc. This is the minimum resolvable angle which you need to see things as separate, right? So a 6 by 60 optotype actually makes an angle of 10 minutes of arc. So what LogMAR tells us is that it takes the logarithm of the minimum angle of resolution. Now, so let's just say that if you are going to take 6 by 12 and you're going to take its minimum angle of resolution, it is going to be 2. So if you're going to take log of 2, you will get 0.3. So this is going to be the value of LogMAR, right? Now, there's one thing I want you to notice is that when we record visual acuity in Snellen, we write this in fraction, right? In which the numerator tells us the distance at which the person is reading the chart, and this tells us the size of the letter, right? So this actually tells us how much is the minimum angle of resolution of the letter, right? Now, the six is the distance at which the person is reading the chart, and 12 tells us that this optotype might be visible to the patient if he or she were reading the letter at the distance of 12 meters, right? This tells us if the person was reading that letter at the distance of 12 meters, he might be able to read that letter. Similarly, if I tell you that 6 by 36, about the 6 by 36 letter, this 36 tells us that 36 meter is the distance at which the person might be able to read that optotype, right? Now, however, in LogMAR, we just write in like this. Why is that so? First, I want you to look at how the LogMAR chart looks like. Now, this is a LogMAR chart, and you can see that there is equal spacing between the optotypes and equal line spacing, right? So there are equal five number of optotypes on each line, right? And there is equal spacing between the optotypes and between the lines. So this is the reason this chart goes like this, right? Now the LogMAR chart starts from 1.0 to 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, and 0, right? And between that, it starts minus 0.1, minus 0.2, and minus 0.3, right? All right. Now, so the first line, 1.0, is equivalent to 6 by 60, and the zero point 0.0 line is tells us that it is equivalent to Snell's 6 by 6, right? But as I told you before, that we are taking the logmar vision in just a, a logarithm, right? There is no distance mentioned. But then where does that distance goes? How do we know that at what distance the logmar is, we are taking visual acuity at what distance with the help of logmar? So we do logmar at a distance of 4 meters, right? Now, a minimum angle of resolution of 6 by 6 letter is 10, right? And if we take 10, logmar of 10, what does it make? If we say, if we multiply this 10 with 5, and why with 5? Because each optotype makes a number of 5, right? So if you have this limb makes an angle of 1, 2, 3, 4, 5, right? So if there are 5 angles, you're going to multiply with 10, which is the minimum angle of resolution, and you will get 50. Now, if we take logmar of 50, you will get what? You will get 1.6, right? Then why do we have 1.0 right over here? There is one simple thing. The distance has been adjusted in these numbers. And how? We do a log bar at the distance of 4 meters, right? Now, if you're going to take log of 4, you will get 0.6, right? Now, if we deduct this 0.6 from 1.6, we will get what? 1.0, right? So the distance has been adjusted in these numbers. So that's the reason we do not have to write the distance separately. Now, if we do have to reduce the distance? I'm going to tell you that later. First, I need to tell you how do you normally record visual acuity and what each optotype has, what each optotype has, what value, right? So each line in LogMAR holds a value of zero point 0.1. As you can tell that the difference between 1.0 and 0.9 is of zero point 0.1. So each line of the LogMAR chart holds a value of zero point 0.1. And we have 5 optotypes in each line. So if we divide 0.1 with 5, we are going to get 0.02. So each optotype in the logmar chart holds a value of 0.02, and each line holds a value of 0.1, right? Now, there are certain methods of recording visual acuity while with the help of a logmar. What if a person reads a whole line of 0.8 and 2 optotypes in the line of zero point 0.7, right? So how are you going to record it? There are two formulas: line fully read minus number of optotypes read in the next line, right? Two, line partially read plus number of optotypes missed in the same line, right? All right. So by using Formula 1, I have said the patient has read the zero point 0.8 line fully, and she has read only two numbers in the zero point 0.7 line. So the number of optotypes are two, which she has read in this, the next line. So this, sorry, this is going to make 0.04, right? And minusing it from, subtracting it from the zero point 0.8, we will get 0.76, right? So by using the second formula, we will have 0.7 plus the number of optotypes missed in the next line. So she has read only two, so she has missed three, right? We are going to get, right? So this is a formula with the help of which you can calculate if the person has partially read a line, right? But what if this calculation was done at a distance of 4 meters, right? But what if you have reduced the distance at 2 meters? Then what you're going to do? So basically, you are partially reducing the distance. So the value of LogMAR at the distance of 4 meters was 0.6. So at the distance of 2 meter, it is going to make what? 0.3, right? So now you're actually going to add, let's say this was read at a distance of 3 meters. So what next? You are going to add 0.3 in it. So what you will get is 1.6, right? And what if the patient was reading the logmar at the distance of 1 meter? So at the distance of 1 meter, you have actually you know reduced the logmar value which was embedded in the reading in the chart scoring. So now you are going to add it this in your recorded visual acuity. You are going to add 0 0.6 at the distance of 1 meter. So if this was done at a distance of 1 meter, you will add what? You will add 0 0.6, right? Now, oh my God, my maths is too poor. Yeah, so you're actually going to get 1.36, right? So this is going to be your logmar value. So this is how you're going to actually record visual acuity with the help of logmar. Now, there is one more thing I want you to understand, is that what are these lines? This one, this one, this one, right? What does these lines tells us? So the most important line over here is this one. What does this line tells us? This line is actually equivalent to Snell's 6 by 18, close to 6 by 18, right? So what does this tells us? This tells the borderline of a low vision person. We know that a low vision person is the one who has the best visual acuity less than 6 by 18. So this is a borderline which tells us that if the person falls in 6 by 18 or not, right? What does this line tells us? This line is, I don't know if you guys are aware of the crowding phenomenon. right? This line is actually equivalent of the Leah symbols. If a child is able to read all the optotypes in this line, this means that the person is not suffering from the carotid phenomenon, and the person is not amblyopic. The patient is not amblyopic, right? So if a child read all the letter in the Leah symbol, and then it reads all the optotypes in this line, this means that the child is not suffering from the crowding phenomenon and the child is not amblyopic, right? And this line is tell, uh, actually tells us that the person is 6 by 6, and below that in the negative reading it tells us that the person vision is so magnificent that it is beyond 6 by 6 and the person can read even far better than 6 by 6, right? Now there is one more way to record visual acuity on LogMAR, which is VAR. And what is that? Visual angle resolution. So it basically tells us all these octatypes together at the 6 by 6 line is going to make a score of 100. So you will actually mark how much scoring does the patient is going to make. You're just going to score your patient's visual acuity out of 100, which means that is it 76 out of 100 or it is 90 out of 100, 96 out of 100, right? So how are you going to record it? The formula is 100 minus 50 log mar. Now, few of my intelligent students always does one thing, that they actually subtracts 100 from the 50, which is obviously going to make 50, and then they take the log mar, which is a very wrong thing to do. So according to the DMAS rule, you first have to, let's say if my patient's visual acuity is zero point 0.3, right? So first I will multiply 0.3 with 50, and I'm getting 15. So subtracting 15 from 100, I will get 85. So 85 is the visual angle resolution score, right? And no, you're not going to document it like this. You are just going to write VAR is equals to 85, right? And a negative score in LogMAR tells us that the vision is good. And in VAR, it is going to be written as 110, 105, right? So it tells us that the vision is beyond 100. It is so perfect that the patient can read beyond 6 by 6, right? So this is the whole thing. Let me know if you guys want another video on what is this minimum angle resolution and how does the eye makes angles, and I want you to ponder on one thing, that how was the person who was making these charts was able to size this letter in millimeters so it will make the exact angle of 6 by 6 or 6 by 18. How can you measure in millimeters to a minimum angle of resolution? So let me know if you want another video on that topic. So I hope I have made everything clear. This was all for today, and stay tuned, subscribe to my channel, like my videos, and share it with your peers. Thank you very much.